Ladies and gentlemen, Teknologi 10 November to deliver his keynote speech. Mr. Heri Trijoyo Purnomo PhD from Institut Teknologi 10 November will moderate this session. Please, Professor Heri and Mr. Heri Trijoyo Purnomo PhD, the time is yours.
Okay, thank you very much for the MC. Yeah, we are moving to the last keynote speaker of the day. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all distinguished guests and participants. Today we are delighted to have Dr. Heri Cosmanto as our keynote speaker. Good afternoon, Prof. Heri.
Good afternoon, Pak Heri.
Okay. Before we start this session, let me read a brief CV of Prof. Heri. Yeah, nowadays Prof. Heri is a professor and the director of postgraduate program of ITS. His research area are time series analysis, big data analytics, econometric, and extreme weather and climate. He got his bachelor and master in statistics from ITS and PhD in statistics from Leibniz Universitat Hannover, Germany. Without further ado, please welcome Prof. Heri Kuswanto. Prof. Heri, the time is yours.
Okay, thank you very much, Pak Heri, and thank you very much also for the invitation to deliver my talk today for all committee. Okay, let me share my slide. Yeah, so this is the title of my presentation for today. So it's about the challenge in weather and climate research and how can we benefit from open data source. So basically, the topic is inspired by my experience of conducting research in the field of weather and climate modeling during past like 15 years. Okay, so I'm from Department of Statistics, Faculty of Science and Data Analytics from Institut 10 November, Indonesia. Okay, so just to remind all of us about what is weather and climate. So I think there is nothing new here. So just to give again the definition of weather is if we are talking about weather, we are talking about some total of short-term variation in atmospheric condition in terms of temperature, pressure, wind, cloud, and precipitation, and so on. So basically, if we are talking about weather, so we are talking about short-term things dealing with the atmospheric condition. And of course, if we are talking about climate, then the duration, the period is a long-term aggregate of weather condition of origin of the globe. So weather is a short-term thing, and then climate, if we are talking about climate, so we are talking about something which is a long-term period. So the scope of the weather and climate research. So what does the climatologist especially doing in weather and climate research? So they study the unique characteristic of atmosphere in controlling the global climate, origin, type of climates, causes and process influencing the climate variation, element of weather, and the impact of climate and human, or vice versa. So by this scope of doing weather and climate research, of course, there are part of the research that can be done by the climatologist, and then there are part of the research that can be done by the climate modeler. And of course, we are a statistician, for example, we can also contribute to this research by doing like developing models for forecasting, for example, or doing impact analysis and so on. I'm going to talk about this later in my next slide. Okay, so I took this slide actually. I mean this part of the slide from the presentation of the IPB University rector last week when we have meeting with Statistical Indonesia. So we are currently facing the three mega disruption. One is a climate change, and then the second one, Industrial Revolution 4.0, and then The third one is pandemic COVID-19. But I'm not going to talk about all of these. This is, I mean, this is not the scope of my talk for today. But the thing that I would like to point out here is about the climate change. Why it is important for us to do climate research, for example. So it's basically deals with the climate change issues. So here we can see the climate change impact currently. So climate change has already impacted a lot or most of the sectors in our life, health, and then ecosystem, food and water, species, and so on. So there is a lot of studies that have already proven that climate change impact is quite dangerous, and it has to be, we are, as scientists, we have to do something. But the point here is that we are, as developing countries, are the most impacted by climate change and the least able to afford its consequence. What does it mean? Okay, we are impacted by the climate change, but what we can do in this case? So my message here will be, we are, as a scientist from developing countries, we have to take part. We have to involve ourselves in the weather and climate research, because there are a lot of things happen, and we are in our country, we know more than.
Recording in progress.
Yeah, we know more about what happened with our climate in our countries. So that's why doing research in weather and climate issues is important for us as a scientist in developing countries. Okay, so we are, as a statistician, for example, there are two major things that we can do dealing with this. So the first thing, dealing with the weather, for example, most of the research are directed to develop early warning system. This is kind of models that can be plugged in the system in order to generate accurate weather condition. And then for the climate, for example, the research has been directed most for studying the climate change impact. So what is inside this topic? We are talking about projection, how to project the climate. So what will be the impact of the climate in the future? So you can see here, for example, the climatologists have already project doing the scenario in order to be able to project what will happen with our climate in the next, for example, 100 years in the future. So the idea is this projection is to direct us in order to be ready for the mitigation action, and then how to deal with the adaptation, and then how to find or how to develop the technology or intervention that might help to combat the global warming. So I think there's two issues that mostly done by us as the statistician instead of the climatologists. So here I cite from the UCL website. This is about data science methodology for weather and climate research. The first thing is about uncertainty quantification, and then data assimilation. Of course, if we are dealing with the climate data set, we need to do something, right? So I will explain a little bit more about this in my next slide. And then the data scientists can also do probabilistic numerics, and then multi-resolution modeling, ensemble modeling, machine learning from climate. So basically, there are a lot of things in the field of weather and climate research we deal with the data science. And yeah, the list you can see here. And here I cite one quote from the Libby Barnes. So she is from the Colorado State University, from the atmospheric Department of Atmospheric Science. I think this is a quite famous department which deals with atmospheric science. So she said that I think we are at the point where we cannot ignore the fact that we, as atmospheric scientists, are all data scientists, which means that the climatologists, for example, they also claim themselves as a data scientist because considering the fact that they also do many things which deal with the data science. Like for example here, if you have a very big data set, for example, large amount of data set, so there are a lot of things that need to be done in order to grab the insight or information from this data set. So about how to select and cleaning the data, and then how to do the transformation in order to have a meaningful data set, and how to mine the data. So this kind of things is also part of the work of the climatologists. That's why they claim themselves also as a data scientist, because the scope of their work is also belong to data science. Now, okay, so this is about challenge on doing weather and climate research. So based on my experience, especially of doing weather and climate research so far, so what I found is that, okay, the data itself, we are talking about data quality. So there is the observation data set, indeed, issued by the like the MDG, for example. But if we go into more detail, if we go in depth on the data set, we will find a lot of missing data set, a lot of missing value. So with, of course, with some causes that we never know why it happened. And then we will find also some anomaly and outlier data set. And another thing is that if we are just doing research with this any particular location here, for example, in Indonesia, then we can only explore what happened in that area. But somehow we need to work in a broader case, like in Indonesia, in the scope of Indonesia, for example. So with this kind of things, of course, we cannot do that without any help for other data set, because in fact, we only have limited number of meteorological stations. So here you can see, for example, this red dot point here. Here represent the station that is available in Indonesia. So which means also if we do research in this area, then we can only do research in these points. I mean, there are a lot of areas that is that we cannot explore what is exactly happened over there. And then this is the most challenging part, is about data access. So my experience working with the weather and climate data, so it's always very challenging for me to get a proper data set. So even though, for example, we already have like agreement with the meteorological office, for example, but in fact, it is not really helpful. So it is not really easy for us to get the data that we that we need for our research. So we still need to deal with some complicated administrative things, and then sometimes the response from the officer is not as fast as I expect, for example. So getting the access to the data is quite challenging. This is at least what I feel so far when I work with the weather and climate research. And then, of course, about limited resources. So I talk here in the context of Indonesia, for example. So we are lack of resources, especially for supercomputer to generate for, let's say, numerical weather prediction. I still remember like 10 years ago when I came back from doing my postdoctoral in Canada. When I came back to Indonesia, at that time, I really confused about what should I do? What can I do with this? Because in my postdoctoral project, I work with numerical weather predict. And NWP, numerical weather prediction, which is generated from a like supercomputer. But in Indonesia, we don't have this data set. So we have to think about what can we do with this. So I cannot stop my research just because we don't have the data in Indonesia. Okay, so this is just to let you know the main source of weather data in Indonesia. We have the Agency for Meteorology, Climatology, and Geophysics, or normally we call BMKG, and we can, of course, get the weather data set from this website, from this link. Of course, there is some registration process that we have to take. But within this data online, we can have or we can download the rainfall data set and then temperature, either maximum, minimum, or average, and then wind speed, wind direction, length of sunlight, and so on. But again, if we came back to this challenge, the quality of the data is not really somehow meet what we expect. So one of the problem is always about there are a lot of missing data set, and doing like imputation for this missing data set is not as easy as having just small value of missing data set. And there are also some sources from the MKG that we can use for climate research. So BMKG have radar here, and then they also have a satellite data set. But then the challenge is, how can we utilize this image data set? One of the things that we can do is, based on this image data set, we can characterize like extreme event. So we can find the profile, what happened with the atmospheric condition prior to the extreme events. But again, I do have an experience for doing this research. At that time, we need like for every 5 second data set, which is slice data set, and the data set is image. But unfortunately, when we try to get the data set, the office doesn't want to share with us the data, and we try to contact the center in Jakarta, but again, it is not successful. So this is very unfortunate condition, because actually we can do a lot of things. There are a lot of information that we can grab from this image data set, but simply because of these administrative issues, administrative problem, then we cannot do the research further. So what can we do with those all limitations that I just mentioned in my previous slide? So here we have the solution about open data source. So what is open data source? Open data source is open data is are large data set that are available to you, me, and anyone with internet connection. So basically, this is really open, and we can simply use the data set and download the data set for the sake of our research. So this is free, and we can download anytime. But the problem, of course, it is normally very big amount of data set that's somehow our internet connection doesn't really work well for this kind of things. So I take this from the statement from the European Commission, why climate data should be open. The first reason is that public data has significant potential for reuse in new products and services. Of course, we cannot just have the data there without doing anything, because there should be something inside the data. There are some significant potential things that can be developed from the data set. And then having more data openly available helps address societal challenge and discover innovative solution. So again, the issue is still the same here in the sense that, of course, if we can work with the data that is open, then we can do like innovation in terms of the research, for example. And then sharing data within and between public sector makes for efficient use of this data. So again, this is about the use of data rather than the data just put there. Then it will be better, of course, if you can do something with this data set. And the last, it fosters participation of citizens in political and social life and increase government transparency. So for most of the developing countries that I noticed so far, they are really open their data. So, I mean, it's quite different with the condition that we have, let's say, in Indonesia. So there are some data that by the officer that don't really want to share the data. But if we try to look at the website of some open data set from developed country, for example, we can find many things for free. So this is about the motivation. Okay, this is an example of open data set. Normally, I use a lot the data set from NOAA to support my research. So NOAA have climate data online, which consists of several weather and climate information inside. But again, I will later mention about what is the challenge to work with this open data source. And then we have also North American multimodal ensemble. So normally they have like the forecast, seasonal and subseasonal forecast that we can utilize to generate forecast in our country, like in Indonesia, for example. And then we have ECMWF, for example. So ECMWF have a lot of open data set. One of them that frequently used in my research and other research is ERA interim data set. So it is considered as the best quality of the data that we can use to support our research to be coupled with the observation data set. And then NCAR, this is also one of the sources that provide a lot of open data source. And here, actually, APRODAT is not belong to NCAR, but NCAR here tries to collect some information about open data that we can use. So we have here APRODAT. This is ASEAN Precipitation Highly Resolved Observation Data Integration. So basically, it managed and developed by in Japan. I don't remember exactly which institution that developed this APRODAT data set, but the nice thing is that they have temperature, and then they have also precipitation with a fine resolution. So it is very good to be used as a proxy for observation. So simply because if we don't have a good data for the observation, if we have difficulty to find the ground observation, then we can use data from APRODAT for our research. And then MERA. So we work a lot with MERA dataset. So MERA is modern era prospective analysis for research and applications. So we take benefit a lot from this, especially as the proxy for observation. But of course, by doing that, we need very clear justification why MERA can be used as a proxy of observation. My experience when we submit our papers to to International Journal of Meteorology, for example, the review really asks about what is justification of using MERA, because they think that there are a lot of choices, but why your choice come to MERA? But fortunately, we have some reasons of using MERA for as the proxy of the observation data set. So this is the characteristic of open data source. So normally open data source, because they are the result of generating scenario. So they have like historical period and then they have the future period. Combining these things, then the periods of the data, of course, that will be very long term. And then they are available in grid data, but with coarse resolution. So you can see here the example of ERA interim data set. They are available in grid data set, but as I mentioned here, that the resolution is not so fine, which means that we need to do something later when we want to use this as data for to be further analyzed for our research. And then the data are available in a specific format, which is somehow not easy for us to deal with the data transformation in order to be readily to be analyzed. And then most of the open data source, they are available, I mean, they cover the global scale, but some of them also cover local scale. Like in NOAA, for example, they have several fields that are really dedicated for local US. But which means that here, with the global scale, like Indonesia, for example, of course, it's belong there. So there is data about Indonesia, and we can use that. And then the data need to be post-processed. Yes, of course, for this one, we need specific expertise in data management, because you can see here that this is a digit data set, and then with a specific format, and then we would like to have the data set to be ready. So it is not easy to work with this to prepare the data in order to be ready to be analyzed. So the challenge here is that how to optimize the use of open data source to be combined with the observation in order to gain the meaningful information from the data. So this is one of the very popular method in weather and climate research. So I think maybe some of you know about data assimilation. So data assimilation is basically a technique by which numerical model data and observation are combined to obtain analysis that best represent the state of the atmospheric phenomena of interest. So you can see here from this figure how they try to combine the observation. This is about ozone observation, and then this is ozone forecast, which is resulted from numerical models. And then with the data assimilation, they will get this result, which is very nice. And of course, it is expected that the result of this data assimilation represent the recent condition of the field that is analyzed. The goal is that what combination of the observation and model information is optimal. So this is the thing that need to be optimized in data assimilation process. I'm not going to talk about the theory of data assimilation, of course, but here I will give some example about the application of data assimilation. So this is the benefit of doing data assimilation. But basically, data assimilation could result on the forecast, like analysis and reanalysis. So as I already mentioned in my previous slide, that a lot of open data source, they are reanalysis data set, something like ERA interim, for example. This is reanalysis data set, which is the result of data assimilation process. So I'm going to skip this one. And yeah, this is just an example of applying data assimilation using Ensembl Kalman filter for Indonesian climate. So the idea is that we would like to get the realization of the Indonesian climate by combining the data, the observation data set. So you can see here the blue dot in this map, and then this is the result of an MMA data set. So we try to assimilate the North America multimodal ensemble forecast with the ground data set, and then we will get the result. This is what happened in Indonesia, and you can see there are a lot of things that it's like a changing. So from this one, by combining the information from this and this, then we get this result that we never know before, that, oh, this is what happened in Indonesia. And then we try also to find or to analyze the performance of assimilating an MMA with the ground data set in Indonesia. So as you can see here from this slide, the R square for any particular location in Indonesia. Yeah, of course, here you can see that the correlation is not that good. So we need to do something more with this. I mean, there are some bias and we need to do bias correction and so on. But at least what I want to show here is that, okay, data assimilation can work with the limitation that we have in terms of the observation in the ground. Now, the second one is about downscaling. So downscaling is very popular method in weather and climate research. So it's basically a procedure to take information known at large scale to make prediction at local scale. And so far we have two kind of downscaling. So we have dynamical downscaling and statistical downscaling. Dynamical downscaling is a little bit complicated. So it tries to downscale, I mean to bring the information from GCM, for example, here to RCM. But the way of doing downscaling here is quite complicated. That's why not so much resources available, not so much data available for dynamical downscaling result. And it is very computational intensive. The nice thing is about statistical downscaling. So I think we are a statistician, for example. This is one of the very nice methods that we can do. And the idea is that we develop a statistical relationship between local climate variable and large-scale predictors. So normally it can be done with a simple regression, for example. Of course, there are a lot of development in statistical downscaling method, but regression is one of the very simple example of doing statistical downscaling. And then the information for global climate model, it will be bring in order to generate the information in the local climate. So this is a very nice method actually, that we can generate something that we don't have before in our local area. And this is one of the example of the work that we do with the statistical downscaling. So actually, it is not just statistical downscaling, but there is also bias correction inside. What we did in this study is that we would like to study the impact of geoengineering. So this is very important for us in developing countries to be involved in this research, because the idea of geoengineering is coming from scientists in developed country, but the impact, we are in developing countries, will be impacted most by geoengineering. That's why we need to do this research. So this is Taylor diagram. the idea is to evaluate the performance of statistical downscaling. I mean, to compare the performance of statistical downscaling and bias correction method. Here we use PCCAQ and then quantile delta mapping and easy method. I take this from the paper that just recently published in International Journal of Climatology. And in this case, we cannot use the ground data set, of course. And then we use MERA2 as the proxy of observation. As I already mentioned, there are a lot of challenges, there are a lot of things that we need to answer why we use MERA2 as the proxy of observation in this case. But so far we found that this is the best data set that we can use. And then it involves, of course, the open data that is available there from the geoengineering model intercomparison project or GeoMIP. So the data is quite big. At the time, we cannot simply download the data with our internet connection here. So during the workshop in Italy, the scientists from developed country bring like hard disks consisting of the data set and give to us the researcher from developing countries in order to be able to carry out this research. And then, so this is the result of this climate projection and impact analysis after downscaling process. Of course, without downscaling, it will be impossible for us to get this map, which able to explain the characteristic in a specific area in Indonesia. So with this data set, we can have the climate projection, of course, and then we can also compare. In this case, what we do is we try to compare the scenario of G4 and RCP 4.5, and then we can also study the anomaly, the level of anomaly, the temperature anomaly for the future after applying the G4. And we can also develop maps here which give us a lot of information about what's going on, what will be the impact of applying geoengineering in Indonesia. And we do have an experience also for applying machine learning here. We work with chart and then random forest for drought classification. And at the time, we still use MERA2 and TRMM data. So why we decide to use this one, because the challenge that I already mentioned, it makes us really confused about what can be further do with that with the observation data set that have a very low quality. So we think about using MERA2 and then TRMM, which is open data source. I mean, these two data sets are openly public, so we can simply use them. And then we can also do like climate zone clustering. So we make use of TRMM data set here, and then we can generate, as you can see here, the climate region in Indonesia. So of course, without the TRMM data set, we cannot use, we wouldn't be able to produce this climate zone cluster. And it is combined with the daily observation data set. Okay, I come to my concluding remarks here that one is the role of data science in weather and climate research is crucial. Yeah, so with the complicated structure of the climate data set, so we need some expertise. In this case, data scientists will play a vital role in order to grab some information, in order to find the pattern, what is going inside the data. And there are some challenges on conducting climate related research in developing countries, of course. So at least this is based on my experience. That's why I currently prefer to use open data for my research. If I can purely use open data source for my research, I will use that without involving observation data set. And then there are always a proxy to observation data set. Of course, there are some degree of bias, and then we need to do like bias correction and so on. And then integrating information from open data with observation data set will lead to beneficial and meaningful information. So my message will be, there are a lot of data available over there, and we can use that data to help to grab some information about what's going on with our country, especially in terms of the weather and climate. So why don't we use that? Because we have the tools, we have the data, we only need to do some post-processing for the data set. Okay, this is the main reference that I use for this presentation. Thank you very much. I can give to Pak Jerry again. Thank you.
Okay, thank you very much, Prof. Heri. Yeah, we have around 3 to 5 minutes to Q&A session. I think perhaps, yeah, we only have 1 or 2 questions. Yeah, okay. Please raise your hand. Yeah, if you have any question or comment. Okay, please raise your hand. Or you can type your question in the chat room. Okay. Okay, we still wait. Just raise your hand.
Another question. Hi, Professor Heri.
Okay,
Hi,
Prof.
Hi, how are
Yeah.
you?
Thanks, nice to see you here.
Yeah, good to see you online again. Thank you so much for sharing your research. Can you just advise researcher like what statistical model they need to learn or to know in weather and climate research?
So could you please repeat again your question?
What types of statistical model, okay, or spatial model they need to learn to do weather and climate research?
Okay. So basically for weather and climate research here, the statistical model is not the one that is very complicated one. Like what I mentioned about downscaling, for example. So we can simply use regression. And then there are like semi-parametric regression also can be used for downscaling.
Mm-hmm.
And then for data assimilation, we can use Ensembl Kalman filter.
Mm-hmm.
But the challenge here is not about the modeling itself. The challenge working with the weather and climate research is more about the data management. So far, what I feel. So it is not really easy to deal with how to prepare the data in order to be ready for analysis. So for the model, I think there are a lot of model that we can use here.
And then relating to weather data, okay, we obtain the data from our Ministry of Environment, right? There are lots of missing data. From your experience, how do you handle the missing data?
Yeah, so I already mentioned that it is not really easy to deal with the data imputation, especially if the number of the missing is quite high, right? Mm-hmm. So sometimes we have 2 months of daily data set get missing. So of course it is very challenging how to deal with this kind of things. So data imputation, of course, it can be applied if we have just small missing data set. So you know also some data imputation method, right? But what I do with my research is that I avoid to work with the observation data set so far. If I can work with the open data source, then I will work with that one without involving observation data set. Simply because one of the reasons is the thing that you mentioned. So the quality of the data is not really good. There are a lot of missing data set and so on. So that's why I prefer to work with the open data in this case. Also, we still need to do something with this data, but it's quite beneficial.
Thank you.
Welcome.
Okay, thank you very much, Prof. Yap and Prof. Heri. I think we are moving to the end of this session. Yeah, again, thank you very much, Prof. Heri. It's very nice presentation. Okay, and I give back the time to the MC. Yeah, good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Yes. Thank you to Professor Dr.rer.pol Heri Kuswanto and Mr. Jari Dwi Trijoyo Purnomo PhD. That was such an intriguing topic that you shared with us. We sincerely appreciate your time and would love to give you a certificate of appreciations for Professor Dr.rer.pol Heri Kuswanto. And also, please, everyone, give us your thumbs up through the Zoom reactions and also applause. Here we have with us certificate of appreciations. To the committee, I will count until 3. Please take the photo. 1, 2, 3. Yes, I suppose the committee already took the photo. Thank you very much, Professor.
Thank you.
Heri. Stop share this.
Thank you, Prof. Heri.
Thank you very much.
Okay, ladies and gentlemen, we have arrived at paper presentation sessions. The sessions will begin in parallel. We would like to inform you, track 1, AI, technique and application will begin in breakout room number 1. Track 2, data analytics and technology will begin in breakout room number 2. To join the breakout rooms, you can click the breakout rooms in your meeting controls. This will display the list of open breakout rooms created by the host. Also, hover the pointer over the number to the right of your breakout room you wish to join and click join, then confirm by clicking the join. Repeat as necessary to join other breakout rooms. Please proceed to your breakout room according to your schedule.